In this video, we will discuss the meaning of the term function. Now, suppose we have two non-empty sets x and y that are subsets of the set of ordinary numbers. The function of x into y simply means a set of ordered pairs of points x, y, where the first entry or coordinate is coming from the set x, and then the second entry or coordinate is coming from the set y, such that no two distinct elements in the set will have same first entries. Remember that if we have a set, say A, that have elements A, B, C, these letters A, B, C are members of this set A, or they are the elements of this set A. But here, the elements of this set simply are the ordered pairs of points x, y, where x is coming from the set x and y is coming from the set y. And we are saying that whenever I pick two different pairs of points, two different elements from this set of ordered pairs, they will not have the same first entries or first coordinate. For example, this set R has these ordered pairs of points as elements. But we can discover that if I pick two different pairs of points, say this point and this point, although they are different elements from this set R, we discover that they have the same first entries. They have the same first entries, which is 3. That is to say that this set is not a function. It is simply a relation or an association that exists between the set x and the set y. But in this second set here, F, we discover that no two distinct elements we pick will have the same first entries. For example, if we should pick this element and this element, they are different elements, and also the first entry here is 4 and the first entry here is 6, which means that the two distinct elements we pick have different first entries. And so this set, although it's a relation, is now a special relation known as function. This set too is also a function because no two distinct elements are picked will have the same first entries. Now, we can observe too here that this 3 is R related to 8. The same 3 is also R related to 16. That is to say that whenever I have one entry from the first coordinate that is related to many entries in the second coordinate, then it is not a function but merely a relation. That is to say that one-to-many relation is not a function. But here we discover that the word under is F related to 5. The word among is also F related to 5. But it is still a function because no two distinct elements will have the same first entries. This implies that many to one relation is also a function. Many to one relation is also a function. Now we can focus our attention to the set that will contain the first entries of this ordered pairs of points. Let's say, for example, in this set F, my focus is on that set that will contain the first entries in each of these pairs of points. Now, if such set is X, then the elements of the set X will be on, from, under, among, and between, because they are the first entries or the first coordinate of these pairs of points. And if I should focus my attention to the set that will then contain the second entries or second coordinate of these other pairs of points, then I'm referring to this set Y whose elements are 2, 4, 5, and 7 because they are the second coordinate of each of these other pairs of points. Now, this set X that contains the first entries or first coordinates of these pairs of points is what we refer to as the domain of this function F. And this set that contains the second entries of these other pairs of points is what we refer to as the range of the function F. Now, any set that contains this set x is what we refer to as the source set of the function f, and any set that contains this set y, which happens to be the range of this function f, is what we refer to as the target set or the codomain of the function. For example, we can discover here that the element belonging to this set y happens to be positive whole numbers. So we can say that the codomain of this set is the set of all natural numbers, because this set of all natural numbers will contain this element that belongs to y. We can also see that this words happens to be prepositional words, and so we can say that the set of prepositions is the subset of this function. Now, in practice, we don't always or normally define a function as a set of ordered pairs of points, whereby no two distinct elements will have the same first coordinate. But we define a function as a rule that assigns unique elements from each domain to a unique element in each range. It assigns unique input in each domain to unique element or image in each range. In that case, we then define the function as y to be equals f of x. Here, this f, which is the function, will assign this variable x from its domain to this variable y in its range. In this case, for example, we can then express this to say that f of on is equals to 2. We can also say that f of among is equals to 5. That is to say that this function f will pick this word on, which happens to be in its domain, and then assigns it or maps it to this number 2 that is in its range, and that is where we get on, 2. This same function f maps or assigns this word among that happens to be in its domain to this number 5 that happens to be in its range. This is how we obtain the domain and range of a function if it is defined in terms of set of ordered pairs of points whereby no two distinct elements have the same first entries.